Right, I'm going to go through some equations. In some cases you just have to balance, in others you have to write them from scratch. But they're all exam questions that have come up in the last few years based on chemical equations. So the first one, you're told that sodium reacts with fluorine to form sodium fluoride. They've given you half the equation, you need to complete it. They've given you the formula for sodium, but you need to fill in the formula for fluorine. Fluorine is an element, and when you've got an element, the first question you need to ask is it diatomic? Because fluorine is in group 7, it is diatomic, so I'm going to have to write F2 as the formula for fluorine, and that gets me my first mark. Now the equation is fully written, I just need to balance it. I've got 2 fluorines on the left, I need 2 fluorines on the right. I've now got 2 sodiums on the right, 2 sodiums on the left. That number 2 gets me my second mark. The next question, and this one came up in your summer exam. The equation between calcium carbonate and nitric acid. What you're going to have to recognise here is calcium carbonate is a base. Any metal oxides, metal hydroxides or metal carbonates are bases. And you're reacting a base with an acid, nitric acid, so what are you going to form? They tell you form calcium nitrate, that is the salt. But as well as forming a salt, if you react an acid and a base, you're going to form water. And in this case, because it's a carbonate base, you're also going to form CO2. The formula for calcium carbonate, they expect you to know, CaCO3. To work that out, you would need to know that a carbonate ion has a 2- charge, CO3 2. Calcium's in group 2 with a +2 charge. Because the charges cancel, that is your formula of calcium carbonate. You then react this with nitric acid. You can learn the formulas of your acids off by heart, or you can use the polyatomic ion to work them out. So it's nitric acid. You do have the nitrate ion, and you're given the nitrate ion there in the question. You need to know that the nitrate ion has a -1 charge. But if you just write this down, that's not the formula of an acid. Acids have to contain hydrogen. So I need to add a hydrogen to this to make it an acid. Because it's got a -1 charge, I only need to add 1 hydrogen to make it an acid. So HNO3 is the formula for nitric acid. That's the left-hand side. On the right-hand side, they give me the formula of the salt, CaNO3 times 2. Because it's an acid-base reaction, I'm also going to form water, H2O. Because it's a carbonate base, I'm forming CO2. 1 mark for the left, 1 mark for the right, and 1 mark for balancing it, which you'll need to do, which you'll do by putting a big 2. Next question. Easier, you just need to add state symbols, but you get 2 marks for being able to do this, okay? State symbols, you've got S, L, G, and A, Q. You're expected to know hydrogen as a gas, the state symbol is G. They tell you oxygen is a gas, and then water is going to be L. It's not AQ, it's only AQ if something is dissolved in water. If it's just pure water itself, the state symbol is going to be L. Right, next question. Dilute hydrochloric acid and marble chips, calcium carbonate. Okay, so again, calcium carbonate, we've just had it, a metal carbonate, it's a base. So I've got an acid reacting with a base, I'm going to form salt, carbon dioxide and water. And they've given you the salt, they told you it's calcium chloride, they told you you've got water, they've told you you've got carbon dioxide. They ask you to complete and balance the equation. So you've got this part of it. You need to write the formula of the salt. Calcium chloride contains calcium and chlorine. It's an ionic compound. You've got a metal and a non-metal, so I use charges to work this out. Group 2 +2 charge, group 7 -1 charge, cross them over, you get CaCl2. Water, you're expected to know is H2O, carbon dioxide is CO2, and then you would need to go back and balance that. 2 chlorines on the right, a big 2 there gives you 2 chlorines on the left, and everything else is balanced. The next one, you're asked to write an ionic equation. So in all the equations I've written so far, I might have used charges to work formulas out, but I never had charges in my final answer. This time though, you're asked for an ionic equation, and that means you actually need to have charges in your equation. And you can see here they've given you an iron ion and a hydroxide ion, and they want you to write the formula of iron 3 hydroxide. So what you're going to do is, again, it's an ionic compound, iron hydroxide. You just need your charges to balance. They tell you Fe as a +3 charge, OH as a - charge. So I'm going to need 3 OHs to cancel out this positive 3 charge. What a lot of you would typically do would be this. If you write it like this, it says you've got 3 hydrogens, but I need to have 3 OHs, not just 3 hydrogens. So I need a bracket around the OH. Now I've got 3 OHs, 1 iron, which cancels out the charges. And you can see here my equation is balanced, 1 iron on each side, 3 OHs on each side. The next one, they give you copper carbonate, they've given it to you, and they want you to react it with sulfuric acid. Again, you can learn this off by heart, or again, you can work it out using your polyatomic ion. Sulfate has an SO4 minus 2, that's its formula. If I want to make this an acid, because it's got a 2 minus charge, I need to give it 2 hydrogens. It's always hydrogen to make it an acid, H2SO4. And I would typically write the hydrogen before the SO4. So that's my sulfuric acid. And then I've got copper sulfate, okay? I already have the formula of my sulfate ion here. I need the formula of a copper ion. Copper is one of your transition metals, but it's got a +2 charge. Because I've got +2 minus 2, the charges immediately cancel, and I get CuSO4, 1 mark for each formula. The next one, nitrogen reacts with oxygen to form nitrogen dioxide. They ask you to finish this equation off. Nitrogen dioxide, it's covalent, because nitrogen and oxygen are both non-metals. When it's covalent, you don't use charges to work things out. You just look at the name and figure out the formula. Di means 2, oxide means oxygen, so it's a nitrogen with 2 oxygens. If you know CO2 is carbon dioxide, NO2 would be nitrogen dioxide, and then you would need to balance. I need to have a big 2 here, 2 nitrogens on each side, 4 oxygens on each side. The next one, they've given you the equation, they just want you to balance it and add state symbols. Potassium is a metal. Because it's a metal, you're expected to know that it's solid. I know it's a metal because it's in group 1. Fluorine, they tell you is a gas. KF, they tell you in the question that it's solid. Potassium fluoride is a solid, so I know that it's S. They don't need to tell you that. It's an ionic compound, and we know that ionic compounds have high melting points because of the strong electrostatic force of attraction between oppositely charged ions, so you would be expected to know that ionic compounds are solid at room temperature. To balance that, I've got 2 fluorines on the left, I need 2 on the right, 2 potassiums on the right, I need 2 potassiums on the left. The next one, you're asked again for an ionic equation, so this time I need to show the charges. It says aluminium ions react with phosphate ions. Aluminium has the symbol Al, but you're asked for the formula of an aluminium ion. You have to show the charge. It's in group 3, so its charge is +3. They give you the formula of the phosphate ion, and they ask you to put them together. +3 minus 3, the charges cancel. Because they cancel, I just whack it together. I don't need to use any other numbers, so I don't need to use brackets. The next one looks like it's going to be difficult, but it's actually quite straightforward. It gives you lots of information about this reaction, but you only really need to look at this last sentence here. Again, complete the ionic equation, so I will show the charges on my ions, for the reaction of calcium carbonate with magnesium ions. So they've given me the calcium carbonate, I need to show it reacting with magnesium ions. Symbol for magnesium is Mg. Because they've asked me for the ion, I need to put the charge. It's in group 2, it's got a +2 charge. To balance this, I have got 2 CO3s here on the right, so I need to have a big 2 there on the left. That now gives me 2 calciums, and I do have 2 calciums, 1 here and 1 here. So that is now balanced. Next one. A balanced reaction or a balanced equation for aluminium and chlorine. So aluminium is by itself, it's an element. Chlorine by itself, it's an element. Aluminium chloride is a compound. If it's an element, I just write down the symbol. It's not diatomic, so I don't need to add a 2. And they haven't asked me for an ionic equation, so I'm not going to put any charges in aluminium. I'm just going to write Al. Chlorine's an element, formula is Cl. It's in group 7. If it's in group 7, it is diatomic. So I'm going to write down Cl2. On the other side, I've got a compound. It's an ionic compound, metal and non-metal. I need to use my charges to work it out. Aluminium +3, because it's in group 3. Chlorine -1, it's in group 7. I cross my charges over, I get AlCl3. It's fine for me to use my charges up here, rough work, to work out my formula. But when I'm just asked for a normal balanced equation, you should not have charges on your answer line. You only use them in your rough work. If you're asked for an ionic equation, it's fine, but if you're asked for a normal balanced equation, don't have them in your final answer. To balance this, 3 chlorines and 2 chlorines, bit of an awkward one, but the lowest number, 3 and 2, divide into evenly is 6. So I'm going to make 6 chlorines on each side, so 3 2s are 6, 2 3s are 6, 2 aluminiums on the right, 2 aluminiums on the left. It's now balanced. Iron is extracted from iron oxide, so this says iron oxide and it gives you the formula, Fe2O3 is reacted with carbon. Carbon is an element, it's not diatomic, so I just write C. It forms iron, iron is an element, it's not diatomic, I write Fe, and carbon dioxide, which I know is CO2. So that's my equation. To balance this, I've got 3 oxygens on the left, 2 on the right, so I'm going to need to use that number 6 again. So I'll put a big 3 there and a 2 there, 2 3s, 6 oxygen, 3 2s, I've got 6 oxygen. I've now got 3 carbons on the right, I need 3 carbons on the left. 2 times 2 is 4 irons on the left, 4 irons on the right. Next one. Again, I've asked for an ionic equation. I'm told that aluminium ions, and I'm given the formula as Al+3, react with hydroxide ions. You are expected to know the formula of a hydroxide ion. We do it in acids and alkalis. It's OH-. So they're my 2 ions, and they're going to react together to give me aluminium hydroxide. So I've got my +3, and I've got my -1. I cross my charges over, and I see that I need to have a 3 down here next to my OH. But again, if I write it this way, I've only got 3 hydrogens, I need 3 hydroxides, so I need to include a bracket. This isn't balanced. I've got 1 aluminium on each side, but I've got 1 hydroxide here and 3 here. To balance, I always use big numbers, so I put a big 3 in front. Next one is really similar. Sodium hydroxide solution is mixed with solution containing, if I want to write the ionic equation. Actually, I'm going to skip that one. Definitely with my app. Skip that one. And to be honest, that's probably enough. That's probably enough for today.